Okay, we're going to talk about direct and inverse variation really quick. Direct variation is not a new concept because all direct variation is just a linear equation, and we've dealt with linear equations a lot. And then there's inverse variation, which is new, but neither one of these is very difficult. So a chili situation, we are dealing with Mr. Gilliland's recipe for chili, which calls for 2 pounds of beef for every 4 servings. Number 1, Mr. G wants to make more than 4 servings of chili. We're going to complete this table to determine how much beef he needs for various servings. Before I do anything, we need to talk about our two variables. I have pounds of beef and number of servings. And in this problem situation, the problem situation we're dealing with, the amount of beef I need depends on how many servings I'm going to have. So the amount of beef is dependent and the servings is independent. That makes my servings X and the amount of beef Y. And that's going to be important for what we're doing in a minute so that we can finish filling in this table, because it's backwards at the moment from what we're used to. What I know is 2 pounds of beef for every 4 servings. Well, they filled that part in, but the next number here is a 6. That's not 4 more servings, but the 8 is. So from 4 to 8 is another 4 servings, which means I need 2 more pounds of beef. So I have to have 4 pounds of beef here. In order to figure out how to fill in these, I need to figure out what my rate of change is. And to do rate of change, it's find our slope. We have to figure out how much does Y change and how much does X change. Well, from here to here, my Y value changed by 2. From here to here, my X value changed by 4. And if I simplify that, it simplifies down to 1/2. And what this tells me is that I need 1 pound of beef for every 2 servings. And so if I go up 2 servings here, I need another pound of beef. So this should be 4. And I went up 2 servings here, so I need to go up another pound of beef, so this should be 5. And so that's how that's going to work. Now, to write an equation to describe the relationship between X pounds of beef and Y the servings, one of the first things I have to know is my rate of change. And right now, I know that my rate of change is 1/2 because I had to find that to fill in the table. If you'll remember to write a linear equation, we always put it in this format, where M is our rate of change and B is our y-intercept, or our starting amount. Well, I know that my rate of change is 1/2, so I know it's going to be y equals 1/2 x. Now let's think about this. My y-intercept, or my B, it has to be where I have 0 servings. And if Mr. G is going to make 0 servings of chili, how much beef does he need? He needs 0 pounds of beef. And so I'm just going to have a plus 0 here, and there's no reason to write it. So this is my equation. And this is not only a linear equation, but it is considered a direct variation equation, and we're going to talk about why. If you look at what's happening in our table, what is happening is that the amount of beef we need increases every time the number of servings we need increases. So both of my quantities, both of my variables are increasing at the same time. When that happens, when both things increase or both things decrease, when they're doing the same thing, they are either both going up or both going down, then what I have is considered a direct variation. Direct variation is just a special kind of linear equation. And we have an equation for it, or a formula, and the formula for all direct variation looks like this. It is y equals kx. K is going to take the place of m here, but they are the same thing. It is your rate of change. We're going to talk about what k is in just a second, but I want to talk about inverse variation. So we have another chili situation. The number of hours, or h, it takes for a block of ice to melt varies inversely with the temperature T. What does this mean? Well, what this means is, if you think about a block of ice and you want it to melt, what is going to happen as the temperature increases? Then the number of hours it takes for my block of ice to melt decreases, because the hotter it gets, the faster my ice will melt. So the amount of time it takes for it to melt decreases. So as one of my variables increases, the other one decreases. Now they're doing opposite things. And when you have 2 variables and one is increasing and the other is decreasing, they're not doing the same thing, then what you have is called inverse variation. And so inverse variation is when one quantity increases and the other one decreases. And there is a formula for inverse variation as well. Inverse variation always looks like this. It is y equals k over x. And in both variation formulas, you will see we have this thing k. Well, I told you in direct variation, k and slope are the same thing. It is your rate of change. It means the same thing in both of them. It is the rate that something is happening, but we're going to call it, it's called the constant of proportionality. And so k is our constant of proportionality, and so it is the rate of change for these problems. It is how quickly or how slowly something is occurring. So let's go back to our ice cube problem, because it asks us if it takes 2 hours for a square inch of ice to melt at 65 degrees, they want us to find the constant of proportionality, or k. So I'm going to go to this formula, y equals kx. And before I figure out what y and x are, I have to know what's independent and what's dependent. Okay? Remember from way back when, first semester, anytime you were dealing with a value of time, almost every time you have time in your problem, it's going to be the independent variable. And then the other thing is going to be the dependent variable. But let's talk about this, okay? If we have an ice cube that is going to melt, how long it takes is going to depend on the temperature. So how long it takes for the ice to melt is totally going to depend on the temperature outside. So this is one of those cases where this is the dependent variable and the temperature is the independent variable. And here's why. We can't control the temperature, or we can control the temperature. You know, if we are in a room with ice and maybe it has a thermostat, we can control the temperature in that room. What we cannot control is how long it takes it to melt. So dependent is going to be y, independent is x. That means my temperature is x and my time is going to be y. So I'm going to plug these in. I know that it takes 2 hours for my ice to melt at 65 degrees. And I want to find out what k is. My entire goal is to find out what does k equal. Okay, so to find the constant of proportionality, I've got to get k all by itself. Well, the only way to do that is to clear this fraction, and the only way to do that is to multiply both sides of this by 65 so that these will cancel out. And when I do 65 times 2, well, 60 times 2 is 120. 65 times 2 will be 130. So my constant of proportionality is 130. And what that means is my ice cube, it's my rate of change. It's how fast or how slow that ice cube is going to melt. And so in this case, we just call it constant proportionality, and it's 130. So let's go back and answer a few more questions. So number 1, Julio's wages vary directly as the number of hours that he works. If his wages for 5 hours are $29.75, so we know his wages vary directly with the number of hours that he works. If his wages for 5 hours are $29.75, how much will they be for 30 hours? Well, we're going to go to this equation that we know, y equals kx. And so we've got to talk about independent and dependent, where they're telling us that his wages vary directly with the number of hours that he works. Well, how much he makes depends on how long he works. So the hours is independent, or x, and his wages is dependent, or y. So I'm going to plug in what I know. 5 hours is going to be how long he works, and $29.75 is how much he makes. The first thing I'm going to have to do is find out what k is so that I can use it to answer the rest of my question. Well, to get this k by itself, I have to divide by 5. So I'm going to divide by 5 on both sides of my equation, and I get that $29.75 divided by 5 is $5.95. And so what that tells me is that Julio makes $5.95 per hour. It's going to be my rate of change. So to figure out how much he makes for 30 hours, I'm just going to do $5.95, which is my k, times 30. And that will give me how much he's going to make. And so I will take that and I will multiply, and I get that he's going to make $178.50. So number 2, we sort of did this. We started this a minute ago. The number of hours it takes for a block of ice to melt varies inversely as the temperature. It takes 2 hours for a square inch of ice to melt. We found that the constant proportionality was 130. We did that just a minute ago. To write the equation that represents this situation, we just plug in the 130 for K, so it becomes Y equals 130 over X. And if I needed to know more information, I could plug it in and then use it, but that is the equation for that situation. So number 3, it's a pretty important question because this is more likely how you'll see this asked. Which of the following equations shows a relationship in which y is inversely proportional to x? Remember, inverse means I have to have y equals k over x. So I have to have y is equal to a value over x. Another way to look at this is if I wanted to have k by itself, if I multiplied both sides of this equation by x, I could say that xy is equal to k. So I could have either equation. I could either have the original one, the y is equal to k over x, so some number over x, or I could have x times y equal to a number. So if you look at number 1, I have x times y is equal to a fraction, and that's totally okay because our k doesn't have to be a whole number. So this one will work because it fits this one. This is number 1. Number 2, however, does not have k over x. What it has is k over x plus 1. Well, that's not what this says. It just says over x, so this one will not work. Neither will this one, because it's not even a division problem, and there's no way to rewrite this to make it a division problem, so this doesn't work either. So the only one that works is 1, which happens to be A. So the time it takes to fly from LA to New York varies inversely with the speed of the plane. If the trip takes 6 hours at 900 kilometers per hour, how long would it take at 800 kilometers per hour? We got to decide what x and y are first. Okay? The time it takes to fly from New York, the time x, varies inversely with the speed y. And I said that backwards. I'm going to apologize. Let's talk about independent, dependent. That's been very, very helpful. If I am flying on a plane, the time it takes to get somewhere totally depends on how fast the plane is going. So this is my dependent variable. This is my independent variable, because the time in this case is going to depend on how fast the plane is going. So we know it's inverse, so it's going to be this formula. And I'm going to plug in what I know. I know that y is the time. Well, it takes 6 hours at 900 kilometers per hour. The first thing I'm going to have to do is find k. So we're going to find out what k is by multiplying both sides of this by 900. And if I do 900 times 6, I get 5,400 equals k. Well, now to find out how long it's going to take at 800, I'm going to plug this back in. So I want to know y equals, if k is 5,400, then speed is 800, and then I just need to divide the two to figure out how long it would take, and it would take 6.75 hours. And so if you wanted to get all technical, it would be 6 hours, and then 3/4 of an hour would be 45 minutes. And either of those answers is acceptable, but you're more likely going to see the second one as an answer choice on a multiple choice test. So last thing here, we want to know if these tables demonstrate a relationship of inverse variation. Remember, in inverse variation, as one variable increases, the other decreases. And so they have to be doing opposite. So if you look at table A, x, the values are increasing, they're getting bigger, and then y, they are decreasing, 30, 15, 10, these are decreasing. So yes, this is an inverse variation, because as x increases, y decreases. Now if you look at table B, my values are increasing, 2, 3, 6 for x, and my y values are also increasing, 6, 9, 18. Since these are both doing the same thing, my arrows are pointing in the same direction, this is not an inverse variation. This one would be direct. This would be a direct variation because the same thing is happening. And in table C, as my x values go up, my y values go down. I have my arrows are going in opposite directions, so this one is a yes also, because as one increases, the other decreases. So that is direct and inverse variation. The two important things to remember are this formula, that's an x by the way, and this formula. And the very first thing you always need to do is find out what K equals so that you can use it to answer the question that's being asked. So figure out whether it's direct or inverse, what's independent, dependent, so you know what to plug in for Y and X, and then use your formula, find K, answer the question. So we'll practice this when you guys come to class tomorrow. I will see you then. Have a good rest of your evening.